Okay, as mentioned in the email above, a boy is attempting to swim directly across a river. He is able to swim at a speed of 5 meters, 0.5 meters per second. Relative to the water, the river is 25 meters wide. The boy ends up at 50 meters downstream from his starting point. A, how fast is the current moving in the river? B, what is the speed of the boy relative to a friend standing on the riverbank? So, I start off by drawing a picture of what's going on. This is the river bank right here. This is the river. It's 25 meters long. We know that the boy is swimming upstream at 0.5 meters per second, but he ends up at 50 meters downstream, which is right here. So the first thing we start off by doing is knowing that he's swimming in that direction to get to 50 meters downstream from where he started. But we know that he's going at a constant speed of 0.5 meters per second upstream. So you start off by knowing what we have and what we don't have. So we have that the velocity of the boy in the water is 0.5 meters per second. We don't have the velocity of the water in respect to the ground. So what we're looking for. So what we do is we start an equation of the velocity of the boy in respect to the ground equals the velocity of the boy in respect to the water plus the velocity of the water in respect to the ground. So we know that we don't need this. This is 0. That's why I put it there. So we have in the y direction. So we have 0.5 meters per second plus 0 equals the velocity of the boy respect to the ground. And you have to do that times sine of cosine of theta. The reason why we do times sine of theta is because in the y direction it is going up right here, and it is the opposite over hypotenuse because if it is right here, so we know that's the opposite of theta. So the first thing we're going to figure out is what theta is so that we can work this problem out. So we come here, we do our triangle, so we know that the river is 25 meters long, and we know that his distance he went was 50 meters across. So what you do is you take the 25 over 50, you do the inverse tangent, and that's how you get the degrees of theta, which is right there. So you come in and you plug it in back right here, and it's 26.57 degrees, and you do 0.5 meters per second over a sine of 26.57 gives you the velocity of the boy with respect to the ground, which equals 1.12 meters per second. So then we come here and we use the information that we know, and now we're looking for the velocity of the boy in respect to the ground in the x direction equals the velocity of the water in respect to the ground. And we know that this is 1.12 meters per second times cosine. Again, because it's going in the x direction, so we're going to multiply that by cosine theta. So you get 1.12 meters per second times cosine of 26.57 equals the velocity of the water in respect to the ground in the x direction, which is 1 meter per second equals the velocity of the water in respect to the ground. That is how you figure out this problem.